Echoes of the unseen, the Amazon's call. The Amazon hides more than just trees, it's a treasure chest of biodiversity. Covering 5.5 million square kilometers, it's the largest rainforest on Earth, home to 390 billion trees and 16,000 species. The Amazon River flows 6,400 kilometers through 9 countries. Researchers have discovered over 40,000 plant species and 2.5 million insect species. More than 2 million people, representing over 350 indigenous groups, reside here. Each year, scientists uncover new species and ancient pathways. This immense green ocean has always beckoned. It calls to the curious, the brave. What secrets lie hidden beneath its dense canopy? The Amazon was, and in many ways still is, a frontier, a place of profound mystery and discovery, a true testament to nature's grandeur. The desire to map the unknown is deeply human. It is part of our nature to explore. We want to see what lies beyond the horizon. The Amazon offered the ultimate challenge. Its sheer size was daunting. Its interior was largely impenetrable. The great green unknown beckoned them forward. First footprints, early cartographers' trials. The earliest European explorers arrived with rudimentary tools. Their maps were often based on fragmented accounts. They relied on brave journeys up unknown rivers. Francisco de Orellana's voyage in 1541 was one such trek. He was the first European to navigate the Amazon's length. His accounts, though sometimes embellished, were groundbreaking. They offered the first glimpses of this watery labyrinth. These initial sketches were far from accurate, but they marked the beginning of a long process, a slow, arduous charting of an immense wilderness. These early mapmakers faced unimaginable challenges. The jungle itself was a formidable barrier. Dense vegetation blocked sightlines. Hidden swamps and treacherous currents tested them. Tropical diseases were a constant threat. Instruments were basic compasses, astrolabes perhaps. Determining longitude was especially difficult then. This led to significant errors in early maps. Rivers appeared in the wrong places. Distances were wildly misjudged. Yet their perseverance was extraordinary. They paddled against strong currents for months. They hacked paths through the undergrowth. They endured heat, humidity, and countless insects. Many expeditions met with disaster. Many explorers never returned. Those who did brought back precious, hard-won data. Whispers of the ancients' indigenous maps. Long before Europeans arrived, the Amazon was home. Indigenous peoples had lived there for millennia. They possessed an intimate knowledge of the land. Their maps were not on paper mostly. They were held in memory, in stories, in songs. They knew the rivers, the trails, the sacred sites. This knowledge was passed down through generations. It was essential for their survival and culture. Their understanding of the forest was profound. They were the original custodians and cartographers. When explorers ventured into the unknown, they often relied on local guides. These indigenous experts knew the safe routes. They understood the rhythms of the rivers. They could identify edible plants and dangerous animals. Their mental maps were incredibly detailed. They could navigate vast distances with precision. Without their help, many expeditions would have failed. Their contribution to mapping the Amazon is immeasurable. Yet it has often been overlooked in historical accounts. Their wisdom was the key to unlocking many secrets. The knowledge held by indigenous communities was, and is, precious. It encompasses not just geography, but ecology. They understand the complex relationships between species. They know the medicinal properties of plants. They have sustainable ways of living within the forest. This deep ecological wisdom is a form of mapping too. It maps the connections that sustain life. The dawn of discovery scientific quests. The 18th and 19th centuries saw a new wave of exploration. This was the age of scientific expeditions. Explorers were not just adventurers or conquerors. They were botanists, zoologists, geographers, men like Alexander von Humboldt and Aimé Bonpland. They traveled extensively in South America. Humboldt's work meticulously documented the natural world. He studied the Amazon's climate, geology, and plant life. His insights transformed scientific understanding. He saw nature as an interconnected web. These scientific quests aimed to catalog the Amazon's riches. Charles-Marie de la Condamine led an expedition in the 1740s. He sought to measure the Earth's circumference at the equator. His journey also involved descending the Amazon. He made important geographical observations. He was one of the first to describe rubber trees, and the properties of the substance we now call rubber. Each expedition brought back specimens and data, filling museums and libraries in Europe. The Amazon was becoming a laboratory for science. Naturalists like Alfred Russel Wallace and Henry Walter Bates followed. They spent years in the Amazon basin. Wallace famously conceived the theory of evolution by natural selection, independently of Charles Darwin during his Amazonian travels. Bates studied insect mimicry, providing strong evidence for evolution. They collected thousands of new species. Their detailed observations painted a vivid picture. Section 5. Eyes in the sky, revolutionizing the view. For centuries, mapping relied on ground-level observation. This was slow, difficult, and often inaccurate in dense jungle. The 20th century brought a revolutionary tool aircraft. Aerial photography changed everything. Suddenly explorers could see the forest from above. They could trace river courses with greater accuracy. They could identify large-scale patterns in the landscape. This was a monumental leap forward. It allowed for the creation of more detailed maps. Vast, previously unmapped areas began to take shape. The first aerial surveys of the Amazon were challenging. Weather conditions were often difficult. Cloud cover frequently obscured the ground. Flying over such remote and vast terrain was risky. Yet, the potential benefits were enormous. Governments and resource companies were keen. They wanted to map the region for development and to understand its natural resources. Aerial photos provided a bird's-eye perspective, revealing features hidden to those on the ground. Then came an even more powerful technology: satellites. From the 1970s onwards, Earth observation satellites transformed mapping. They provided regular, comprehensive coverage of the entire Amazon. Instruments like Landsat captured images in different light spectrums. This allowed scientists to see more than just the surface. Section 6. Peering through the green veil. Remote sensing's power. Remote sensing is more than just taking pictures from space. It involves a suite of sophisticated technologies. These tools allow us to see in ways our eyes cannot. Radar, for instance, can penetrate cloud cover. This is crucial in a region as cloudy as the Amazon. It can also reveal the topography beneath the forest canopy, showing subtle variations in ground elevation. This helps in understanding drainage patterns and identifying potential archaeological sites. It is like having X-ray vision for the landscape. One particularly exciting technology is LiDAR. LiDAR stands for light detection and ranging. It works by sending out laser pulses. These pulses bounce off the vegetation and the ground. By measuring the return times, scientists can create three-dimensional maps. These maps show the structure of the forest, including the height of trees and the density of the canopy. Remarkably, some laser pulses reach the forest floor, revealing the terrain hidden beneath the leaves. It's a digital deforestation without cutting a single tree. Section 7. Boots on the ground, the human touch and discovery. Technology provides an incredible overview. Satellites and aircraft give us the big picture, but they cannot tell us everything. There is no substitute for fieldwork, for scientists and researchers on the ground. They are the ones who verify the remote data. They collect samples, make detailed observations, they study the intricate workings of the ecosystem. This ground truthing is absolutely essential. It bridges the gap between pixels and reality. Fieldwork in the Amazon remains a significant challenge. The environment is demanding. Heat, humidity, insects, and difficult terrain persist. Reaching remote areas can require long journeys by boat, on foot, or by small aircraft. Researchers often live in basic conditions for weeks or months. They face risks from wildlife and disease. Yet their dedication is unwavering, driven by a passion for discovery and a desire to understand this complex world. On the ground, scientists unravel the Amazon's secrets. Botanists identify new plant species. Zoologists track elusive animals using camera traps or radio collars. Section 8. Cataloging life's library, mapping biodiversity. Mapping the Amazon is not just about geography, it is also about mapping its incredible biodiversity. This rainforest is home to an astonishing array of life. Millions of species, many still unknown to science. Scientists are in a race against time to discover and document this biodiversity before it is lost due to deforestation and other threats. This task is monumental. It requires meticulous collection and identification, a global effort to catalog life itself. Modern tools are aiding this biological exploration. Camera traps capture images of shy, nocturnal animals. Acoustic sensors record the calls of birds, frogs, and insects, helping to identify species and monitor their populations. Environmental DNA, or eDNA, is a powerful new technique. Scientists can collect water or soil samples and detect traces of DNA shed by organisms. This reveals what species are present in an area without ever needing to see or capture them. It's like an invisible net, catching genetic clues. Section 9. The Unfolding Map. Charting the Amazon's Future. The exploration of the Amazon is far from over. Even with advanced technology, vast areas remain understudied. There are still remote tributaries to explore, deep forest interiors that hold untold secrets. New species are discovered regularly. New archaeological sites continue to be found. The map of the Amazon is still unfolding. Each discovery adds more detail, more complexity. It reveals a world even richer and more fascinating than we previously imagined. However, this ongoing discovery occurs against a backdrop of threat. Deforestation continues to shrink the rainforest. Agriculture, logging, mining, and infrastructure projects all exert immense pressure on this fragile ecosystem. Climate change brings new challenges, such as increased droughts and forest fires. The Amazon is at a critical juncture. Its future and the future of its biodiversity hangs in the balance. The urgency to understand and protect it has never been greater. Its fate is intertwined with our own. Continued exploration and mapping are vital tools for conservation. By understanding the Amazon better, we can protect it more effectively. Monitoring changes helps us identify threats early.